there's 2-unit operations in the technology. What we are trying to do here is essentially replicate the rain cycle, but in a confined space and in a very short period of time. So we have 2-unit operations. One's called a humidifier and another is called a bubble column dehumidifier. So the humidifier, think about it as a tall tower with a bunch of packing inside of it. We take the dirty water, we heat it up. Now that heating can be done with any low temperature thermal source. So wherever there is cheap or free gas available, we use that, like in the oil fields. We can use low temperature solar thermal, and we can use waste heat. Now this waste heat aspect comes very handy when we are dealing with industrial customers like power plants, because they have so much waste heat that would otherwise be rejected and as hot water, for example, but we can actually utilize that, so that reduces or eliminates the energy costs. So anyway, coming back to, we heat up the water, it goes up to the top of the humidifier and drips from there. We take carrier gas, which in this case is just air, dry air, ambient air, which comes in from the bottom, and as the water comes down and the air goes up, they come in contact on this packing material. All the packing material does is provide surface area for that absorption, the evaporation process. The air picks up the pure water vapor, leaves behind the salts and other contaminants, which get to the bottom as a saturated brine. By the time the air gets to the top of the humidifier, it's hot and humid. It's basically carrying, it's pure air carrying pure vapor. So we're essentially created the cloud. Now we have to create the rain. So we go into this bubble column, which is multi-staged. So you have a tower with a bunch of perforated plates going right through it. So if you imagine, each of these stages has holes in the bottom of it. On top of each of these plates sits a shallow pool of ambient temperature or cold fresh water. As this humid air comes through the bottom of the bubble column, it passes through these holes, and naturally it starts bubbling through these shallow pools of water. Hence it's called the bubble column. And then as that bubbling happens, this is a very rapid heat transfer and mixing process. So what that does is that cools the air down, and therefore it condenses the water back out that it had picked up, because it can no longer carry all that humidity. You know how humid air, the temperature reduces and you get dew, exactly, that's what we're getting. So each of these liquid columns keeps increasing in height because you're adding more pure water to it, and then we just have overflow ports so that when the liquid column hits the overflow port, it falls to the sump, to the bottom, where we collect it as our fresh water. By the time the air is past the last stage of the bubble column, it's cold and dry again, and then it can either be ejected or recycled in closed loop. So very simple. Obviously, this is a brief introduction to it. There's many more aspects that actually make it work and actually make it efficient. But that's the concept, how we desalinate high contamination water into fresh water. Remember, it's low temperature, it is ambient pressure, so we're not using any pressures or vacuums, it's just that regular pressure. We're using, because it's a simple process, we're not using high temperatures, we're not using high pressures. Our materials of construction are simple and therefore inexpensive. We're not using large heat exchangers made of exotic metals, because when your salinity goes up, you need higher quality material so that it doesn't get corroded. Here we do not need that. We constrain the use of exotic metals to a very small area. We have decoupled the separation process, where the salt separates, from the heat recovery process, which is in this multi-stage bubble column, which both reduces the need for pretreatment, cost for pretreatment, and I can go into more, of course, but other innovations that reduce our energy consumptions as well. So our plants, our systems sit in the middle of the customer's operations, whether they are oil fields or power plant, for example. And we treat this continuously. These are plants that are running 24/7. They are treating water as it's coming in from the operations. Our current operations in the US are treating 12,000 barrels a day, or if you think in terms of cubic meters, that's 2,000 cubic meters a day, or 2 million liters per day. That's the extent of, or 500,000 gallons a day. So that's the size of the system. So they're fairly large throughput rates. Of course, they're small compared to, say, a city effluent treatment plant. The projects that we are developing overseas are actually 10 to 20 times larger than those projects we're doing in the US. Now, that is, from a scaling standpoint, that's not an issue because we're not necessarily building larger units, we're just building more of them. It's a modular technology. So that hopefully gives you an idea of the scales that we operate at.